All right, hello everybody. Welcome to my talk. This is Legacy Applications on Kubernetes. So if you don't know who I am, I'm Joshua Timberman and I work for Chef. I've worked here for 10 years and I've pretty much done all the things. Please give me a show of hands if you've never seen me present before. Okay, well you're new here, it's okay. I'll forgive you. But why are we here today? Why am I talking to you about Kubernetes at ChefConf, right? Like you could be at KubeCon in Barcelona, sounds like a pretty dope time, but here you are in Seattle instead, so, you know, I think that's also pretty cool. I want to talk about running legacy applications on Kubernetes. And actually what it really is just running heritage applications, right? First of all, who has legacy applications in their infrastructure? Has some old crufty stuff that hasn't been touched in like 5 or 25 years, right? Who's running COBOL apps? Heck yeah. This shit runs the world. But how does Chef, a startup, a 10-year-old company, have legacy applications? Well, as Corey said, they're heritage applications, right? They've been put into production and they're running and nobody's like updating them because they're just going. You got some stuff out there that's running, it just goes, and everybody's kind of a little bit afraid to touch it, right? But you know, you end up with this stuff as your business grows over the years, especially if you work for a company like IBM or any bank, really, right? They all have like lots of stuff. Who works for a company that's older than 50 years? A few people, and how many of you are running applications that were written in the 50s, right? So Chef operations team, we run many applications. We run primarily hosted Chef, but we also have the download site where you get Chef and all of our Chef products, the OmniTruck API service. We have Learn Chef is another component that the operations team runs for the business. We have the community cookbook site, which Rob Kidd runs, but he's an honorary operations team member. And then we have a number of internal and external utility sites that glue together various things like Salesforce to the billing service and that kind of thing. And then of course, since we're talking about Kubernetes, we have to run Kubernetes itself. It's an application. But as it turns out, what mattered most for us was the automation workflow when it came to getting our applications out into production. And we found that it was hugely important. And legacy workflows just don't work. They were abandoned for the new shiny thing, right? We have to chase the shiny object in technology, right? It's a thing that happens all the time. And for us, our workflow is centered around using Slack and ChatOps, and so we ended up with a bunch of emoji soup because all the tools that we use support emojis, so you know, icons are fun, and we get to have a little party cloud over there. So what motivated us to pick Kubernetes? Like why would we go with it? I mean, obviously the cloud native inertia is quite large, right? And we wanted to be buzzword compliant. I mean, hosted Chef is literally a Chef server in the cloud, right? So we've embraced running things that are cloud native and that kind of thing. But more to the point, what we wanted out of Kubernetes was platform consistency. For all these old applications, we wanted one place where we could run them so that we didn't have this disparate number of platforms that we had. We had a variety of different workflows and deployment models, and we used our own Chef delivery product for a while. But as we diverged in other parts of the business, like the way that we build and release Automate and the, other Chef products, we weren't doing things in the same way. So we wanted to bring that in and have cohesion with our workflow. We wanted to simplify these several ways that we were building and deploying applications and services. And one strong benefit of Kubernetes for us was that it was cost savings. With delivery, where you have, if you're familiar with delivery, you would know that it has 4 different distinct environments that the applications run in. And if you're following that deployment model, then you end up with 4 different instances running your application out in EC2 or Azure or whatever else. And so that list of applications, that is not a complete list. We have like 15 distinct apps that we're all running 4 to 8 instances apiece, depending on if they were production, they had at least 3, but there was also the non-production environments. And now with our Kubernetes cluster, it's only 9 nodes, but we're running 9 instances versus 4 or 6 times 15 to 20 apps, right? So that cost savings is pretty huge. But at the end of the day, a lot of times we're just like pushing peas around the plate, right? We're managing applications running on EC2 instances, and we're running Chef on those, and like that's all great. But with Kubernetes, we get to just like take that scoop of mashed potatoes, pick up all those peas, and then gobble it up. I just wanted to use that analogy, and I thought that was more fun. But Joshua, what about Chef Infra? If you're using Kubernetes and you're using Docker containers, you don't need Chef anymore, right? Right? Who has that question? Come on, more hands. I know more of you have that question. I've been talking to some of you this week. But as it turns out, we still have an operating system. And that operating system is running the Kubernetes applications itself. The etcd service and the kubelet service and the proxy and Docker and like all those things are still running on an operating system. You could say, but we're using Kubernetes as a service. Amazon solved that problem. Well, you're probably not running a whole lot of legacy applications if you're cool enough to be using like the latest feature of Amazon Web Services. Because all these old companies with old software just jump on the latest new AWS offering, right? Anyone? Right, you don't have heritage applications that you're going to be putting into this kind of thing. So, Kubernetes itself, as it turns out, is a less interesting portion of what we've been doing because we're still using Chef Infra. We still manage the operating system of Kubernetes with Chef. And we still have other applications, like Hosted Chef runs front-end applications that are running on EC2 instances. And we use Chef for that. And then we use Chef for the Kubernetes nodes and masters. And one of the things that we're doing with that is we're using policy files. And I'm going to get a little more in detail about what we're doing with that. And then we're using Chef Inspec, because we want to validate our systems are compliant with our various security policies. And we use Inspec for Test Kitchen, where we're testing the cookbooks that we're going to put into our policy file. Then we also adopted the DevSec Linux baseline, which is a server hardening framework. You can download their profiles and use those, and that will automatically scan for, do you have a minimum number of days for passwords in your password configuration? Do you have certain ports that should not be running? Are you using NFS? Like, these are all like industry standard baseline practices for security. And then we're also using a bunch of AWS. We have 30 different AWS accounts across different departments and different functions that we've done over the years. And we have a CIS AWS benchmark that the Inspec team has produced as that premium content that we have available. If you saw the keynote, you saw the list of all these benchmark profiles you can get along with Automate, and we're using that to scan all of our AWS accounts, including the AWS account where all the Kubernetes nodes run. And of course, we're using Chef Habitat, because that's what we want to use to package and manage and deploy all of our applications. Most of the applications that we're talking about here are Ruby, because as it may be very surprising to a lot of people who use Chef that we use a lot of Ruby over the years. And the Ruby scaffolding makes it easy to package that. So this is a list of the scaffoldings that are available in the Habitat core plans. So these are already pre-baked best practices for deploying these kinds of applications using Habitat. So we have Node, we have Ruby, there's Gradle, we have Go. There's been work on Java, then there wasn't because there's a lot of options in Catalina, so we didn't want to get too far into that. But there's lots of options for building and deploying these kinds of applications using Habitat. So we took that, and we're using that to package up our apps. And we're going to move to Effortless Config. This is, as you all know, is a very newly announced thing, and the use of it internally was not encouraged yet because we weren't finished building it so that we could do things at ChefConf for it. But it's coming along, and we will be deploying more things with Effortless Config. So that's kind of what we're doing and what we're using. But how did we get there? Well, the first thing we did was we stood up a Kubernetes cluster. Victory achieved, right? Who is not familiar with Kubernetes? A few hands, okay. So if you're not familiar with Kubernetes, here's some word soup. It's a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. Sounds pretty cool. If you actually use Kubernetes, you know that it's Docker as a service. It's a gross oversimplification, but really what it is, it's all about YAML. Spent a lot of time like looking at that because white space, it's really hard. So the way we stood up the Kubernetes cluster is we used Kops. Kops is Kubernetes operations. It is a tool where you run a command and you give it some arguments and then it will spit out YAML. We're not sad about that because I didn't have to write this, it just generated it for me. But in here is a comment right about in the middle where we have a shell script that installs, configures, and runs Chef. And this is additional user data that gets passed into the EC2 instances that it manages. And what this configuration does is it ends up launching instances in EC2 and setting up security groups and VPCs and all the networking, and then it labels and tags it all so that it can all work together and know which masters and nodes you have. So there's a bunch of different options and more things you can put in here. The nodes and masters, the main difference is the size of machines, the number that you use, and whether it is a node or a master. Like, those are the main differences. I could paste the same YAML file for all the other things, but it's basically the same content. That shell script is actually going to end up looking something like this when we move to Effortless Config. Right now, it is a thing that does a curl of the OmniTruck API to do bash to install Chef with a specific version, and then we write out a Chef server config file. But we'll move it all to Effortless, which will end up installing Habitat and then running the hab package exec with Chef client to run our initial run of Chef, and then that will have everything running the entire Chef client thing that we want with all the cookbooks that we have that configure our node. And the node gets its configuration from a Chef infra policy file. And that policy file has cookbooks in it for doing user management. We use LDAP, so we have centralized logins, and then it also drops off our SSH keys. We do centralized logging, so we want to send everything to our ELK stack that we do all of our logging through. And then we have inspect profile data that gets sent over to a Chef Automate server. And then we also keep the Chef Infra package updated. When we move to Effortless Config, that recipe just won't get used. We'll disable that option, but it's the Chef Client Updater Cookbook, if you've seen that before. And then it ensures that Chef Infra is running it as a service. And again, Effortless Config will just do that. But this is pretty simple. But we still have to maintain our OS. We still have to harden the OS and make sure that this Debbie and Jesse AMI image that it came from 2018, I'm sure that there's been a couple of updates to that. So we might want to install packages and ensure that we're doing all those things. So the next thing we did after we stood up Kubernetes was we configured our new CI and CD continuous integration. And that's central to what we do for our workflow. And what we did was we went with Buildkite, which is a CI as a service. And it's pretty cool. You run a Buildkite agent on any number of machines that you want to be workers, and then Buildkite will dispatch your build jobs out to those workers. And that's how we build Automate. That's how we build these packages that we run for all these applications. And then we have a little bit of a glue service called Expeditor. And you should go listen to Tom and Scott talk about Expeditor and Buildkite and all the release engineering stuff. They're speaking tomorrow, I believe. So definitely check that out. They'll go into more detail about what Expeditor is and does. But the very smallest distilled description is that Expeditor listens to webhooks and then takes actions. So Buildkite is a software as a service. GitHub is a software as a service. They send and receive webhooks. They can send them to Slack. You can have Slack send a message that tells Buildhook to kick off a build, and we can integrate all those things together that way. Does that all make sense? Anybody completely lost and confused at this point? Okay, good. It's okay if you don't admit it too. All right, so most importantly, with the way that we configure our Buildkite pipelines is that we have an Expeditor configuration where we describe in YAML what those pipelines are and what the definitions are. Like these Expeditor deploy pipeline.yml is more YAML, and that's what actually does the deployment to Kubernetes. So after we merge a pull request that has that GitHub or has that Expeditor configuration in it, then it will automatically, Expeditor will automatically create these pipelines because it gets a webhook from that repository saying, I've got some config, go do the thing. It goes and does the thing, and then Buildkite then has pipelines. For example, these are the pipelines that are for the Learn Chef backend, which is a part of the Learn Chef Rally site. Who's not used Learn Chef? Okay. So you should check that out because it's awesome, and it runs in Kubernetes, as it turns out. So another thing that it does after you've merged this configuration in is it will trigger Habitat packages to be built. And the reason we're not using Habitat Builder for this is because of reasons. There's a number of reasons. I believe Tom and Scott might go into some of that with their talk, but they may not. The reasons are actually uninteresting at this point. It was just, there was features that we needed that it wasn't going to accomplish, so Expeditor was able to take care of those. And really, it's doing the same kind of thing as you would do on your laptop for local development, or that you saw in the demos this morning, where you do a Hab Studio enter, and then you do build, and then when it's done building, you can upload that package to Builder, and you can give it channels. So these channels are important because that's how it determines what thing it's going to deploy in Kubernetes to production or into acceptance. And then after we've built the package and pushed it to Builder, we can also export it to a Docker image and push that Docker image on out to Docker Hub. And then Buildkite deploys all these changes to Kubernetes. So we have these definitions that say how we're going to deploy, and then that ends up putting a bunch of Kubernetes resources in Kubernetes, and then our application is running there. Now, there's some other things along the way that we have to take care of, like secrets, right? In order to talk with all these services, we have to have like authentication to the Habitat build service so that we can publish packages there. We have to have an SSL certificate for our front-end web-facing nodes and that sort of thing. So we have all these different things that we're managing for secrets, and I don't know if you know this, but secrets management is actually the hardest problem in computer science. It isn't off by one errors or cache invalidation or naming things, it's actually secrets management. Fortunately, HashiCorp has created a tool that is pretty dope, and we are using that for a lot of these secrets within our build environment. And then because of the way that Kubernetes itself works is we're also using some Kubernetes secrets, which are largely the runtime secrets that we need. Like we need to set a Twitter session ID so that we can get tweets from our Twitter account and then feed them into something else. We have a little app that does that kind of thing. And then those are environment variables we pass into the Habitat services that we're running using the user.toml. Remember the hab config apply that was run on stage? That's running a command that is uploading a toml file into the service. And this does the same kind of thing, where the way that we're running our Docker containers that are Habitat packages, they're going to be able to find those secret, or that toml file in a Kubernetes secret. So after we took care of getting all of our secrets and our repositories and our pipelines set up, we had to migrate our applications, right? This is actually the hardest part, right? Like all that other stuff takes 20 minutes, depending on how fast you click merge on your GitHub pull request. But we also had to do things like create a Habitat package. And like I said earlier, we use the Ruby scaffolding for the majority of our applications. And what the Habitat package looks like is a plan like this, where we're going to have a package name. This could be Learn Chef Backend, it could be OmniTruck, Downloads, whatever the name of the app is. Then we give it the origin, which is our origin is ChefOps. Yours could be Acme Co. It could be IBM. I don't know where you work, but you generally would have your origin be whatever your organization name is. We give it a version. We populate some metadata about the maintainer and license, and then we tell it what the dependencies of this particular application are. So the runtime dependency of the app that I copied this from is core utils. That's all it needs in order to be able to run is the core utils package, and that comes with like all the Unix core utilities, right? But then we also have some other things in order to build the package that aren't going to be needed at runtime. So with Habitat, it's going to download all the things in the studio that it needs to build the application. So we need make, GCC, and tar, because we're going to untar some tarball, and then we're going to run /configure make install, and it's going to compile a C application or something like that. Or we're going to have, like in our case here with this Ruby application, we probably have something that has no Kogiri in it. Don't worry, the Ruby scaffolding has solved no Kogiri for your legacy Ruby applications, so we're good there. So those build dependencies will end up in your studio when you build, but they will not end up in the resulting image once you have exported your Docker container. So you won't have compilers and make tools on your running production containers. So that helps reduce size and helps reduce attack vector areas. Then we tell it that we're going to use the package scaffolding, core scaffolding Ruby. That was one of those directories I listed earlier. And that has a bunch of sane defaults for being able to build a Ruby on Rails or a Ruby Sinatra application. We also tell it where or what version of Ruby we want to use. I knew when I wrote this app that we have a .ruby version file, and then I told it what version of Ruby I need, and that is going to put exactly that version of Ruby on the system when it needs to run the application. Habitat will take care of that. It'll be included in the exported Docker container. And then we also have a number of scaffolding environment variables that are going to be used. Like I said earlier, those environment variables are part of the configuration. We moved all of our runtime configuration out of config files that we littered across the file system, and like you might have seen with Tomcat applications where you have 5 different properties files, right? We had 5 different config files, and we consolidated those all into something that just gets loaded up at runtime through these environment variables. All right, so the how of the Expeditor and Buildkite. So Expeditor and Buildkite give us the pipeline definitions. That's in Expeditor's configuration file, config.yml. And then this is just scripts that are run by the pipelines in Buildkite. Who was at the Chef Summit yesterday and was at the conversation about the community distribution of Chef? So a couple people, I remember seeing some people around there. This is stuff that we do also for building our distributions of Chef and Chef Infra and Chef Automate and that sort of thing. And Expeditor is really just taking a list of things from a YAML file and then running scripts in Buildkite. They're just little shell scripts. It's not super exciting. I wish Expeditor was open source sometimes, but it's not. So that's what it does. It's not magic. But it does do a cool thing with running scripts where we can do the Kubernetes deployment. So who's not used Kubernetes or is not familiar with Kubernetes? Show of hands. Hands up, if you've never used Kubernetes or if you're like unfamiliar with it. Okay, cool. So I just want to make sure that this is going to be useful information. So here's the kubernetes.sh script. It delightfully fits on the slide. I guess it's hard to read, so I'll tell you what it does. It is the deploy pipeline in Buildkite is going to run this script. And it's going to get a few environment variables that get passed in. If you saw like that app name and the environment were in a previous YAML thing, that gets passed into this. Then when it runs, it's going to copy the credentials used for kubectl. Those are stored in in an S3 bucket that we have authenticated with an IAM user role, and it downloads those credentials so that it can run kubectl against the Kubernetes cluster. Then it retrieves the habitat package information from Builder, talking to Builder's API directly, and then it uses that information to tell those Kubernetes resources via the Kubernetes deployment.yml manifest which package version to install for the Docker container. And then it will wait until there's an ELB available, if there is an ELB. So in Kubernetes, you can have a service resource, and for us, we're using Kops, it creates an Amazon ELB. So it's pretty cool. And then once it's done waiting, it's successful, and it reports back that the build succeeded. The habitat package information that it needs are the version, the release, and the channel. And it does that with a function called getImageTag, and it's just curling the Builder API for the package name that we're using. So chefops/learnchef-backend, chefops/downloads. It gets that, and it exports it in this image tag environment variable, and then that gets used in the Kubernetes deployment.yml, and we literally run a kubectl apply-f standard out, and it will, or standard in, and it will create those resources. And this YAML file is an ERB template because we like to herb our YAML since we're Rubyists, and that's just a thing we've been doing for a while. There are other ways you can go about doing this with Kubernetes. So like if you want to use JSONnet or one of these other things that Kubernetes supports, then you can put whatever the equivalent command would be to run kubectl. So Kubernetes resources that we have when we've deployed an application, we'll have pods, which are running instances of the Docker containers that we created with Habitat. They will have stateful sets and deployments depending on what kind of way we're deploying these applications. There's a couple of subtle differences as you get down into the weeds of Kubernetes details. Then we have a service. We put everything into a namespace. So we have a namespace for downloads. We have a namespace for OmniTruck, a namespace for one of our utility apps. We put all the apps in their own namespaces because it was the easiest way to ensure that they were isolated away from each other. And then there's also custom resource definitions. So you have a number of resources that are written in your YAML file, and a CRD can simplify that by just defining all that for you, and then you can give it a different kind of resource, and we'll take a look at what that looks like in a moment. CRDs are API extensions that are often called operators. So there's a Habitat operator, there is a Prometheus operator for monitoring, there is operators for a whole host of different things for Kubernetes. So here is the entirety of our deployment.yml file. The first section is the namespace. So each namespace isolates the resources in the cluster into virtual clusters, and each one of our applications gets a namespace. So I did this with an Nginx demo, but this could be OmniTruck or LearnChef or Foobar or whatever it is. Then the next resource we have is the Habitat CRD, the Habitat operator, and this defines a Habitat resource. We give it some metadata, and note that all of our applications are segregated by environment in their naming, so we'll see some example of that here shortly. And then we also tell it which image we're going to get. So we're going to get the ChefOps Nginx demo image that's going to come from Docker Hub, and that image tag is going to be whatever the tag from our particular environment is. So if this was acceptance, then it would get the acceptance tag, and that get image tag would correspond to the correct version. Does that all make sense? The service is going to be an ELB in our case because we're using AWS. If you're using Azure or Google Cloud, it would be whatever their equivalent is. Kops has all that built into it as the way that it sets up your cluster for you, so it's pretty cool. The Habitat name in the selector is how the ELB knows which instances or which pods are going to be the instances of the ELB. So it maps each of those to a port that's running on the Kubernetes node where those pods live. And we can also add other parameters in here, like port 443 for things that need SSL, and then we can give it some values for like the SSL ARN for our AWS SSL Magic certificate stuff, which is pretty cool. And then when we run this pipeline, what we'll get is we'll get some pods. So if I run on my laptop kubectl get pods -n omnitruck, then I will have all these pods. Now omnitruck is a special application because it has pods that not only run the external service, that when you go get something from omnitruck, download a version of Chef or InSpec or Chef Workstation, it will hit one of these instances. But we also have a puller, which is a cron job, and those cron jobs run in a pod. And that cron job for Polar is going to go and pull Omnitruck's data so that it can populate all of the latest versions of all the applications for all the various platforms, so that you can download Chef Infra Client 13.12. Whatever for AIX version 5. And like all that mapping is done via Polar, and that's where those pods come from. The one that's running, as you can see here, this Polar acceptance was running, so it was literally updating that on the acceptance environment when I ran this command an hour ago. And then if we get services, we'll see that we have an acceptance load balancer and a production load balancer. One of the coolest things about this is that our acceptance environment and our production environment are exactly the same, other than the number of pods. We run 2 in acceptance and we run 3 or 4 in production, depending on the app. I think it's important to note that we're only running stateless services in Kubernetes. All of the things that are in Kubernetes that we're doing with all this are all stateless. They're all web front-end type services. We do all of the back-end services, all the data stateful services, usually as a AWS RDS or Elastic Cache or Elasticsearch, depending on what the app needs and what the app is doing. So what about monitoring? How do we monitor all this stuff now that we've got it running? I mean, these days we have to say observability, right? But what do we do in a world of Kubernetes where we don't have observability into the OS of the containers? We're not going to go and run Nagios agent to make sure that all our containers are up, right? Well, what we do is we have Prometheus and Grafana. So we use the Prometheus operator that is by the CoreOS project. And the Prometheus operator gives you all the things you would need to run Prometheus inside your Kubernetes cluster. And it gives you a bunch of basic built-in things to understand and see the health of the system. And then you can use those as, use that data as sources for Grafana. Or you can use it for sources of whatever other graphing tool you might use for your environment. And so, for example, this is a custom dashboard we created in Grafana that has a multi-view of pods. By default, it comes with one that's the little drop-down up at the top. The pod prefix is actually just a list of all the pods in that namespace, so it's kind of arduous. So we built this one using the Prometheus operator and Grafana to make nice graphs. So this has worked out really well for us. It was a couple hours of work for a couple of our operations people to get that set up, so it wasn't terribly difficult, and then we just get this for every single thing we deploy in Kubernetes. So if I were to build a new application and then deploy it through one of these pipelines, it will automatically start showing up in here. And we get that for free with the Prometheus operator. Now we also want to know about the uptime of our apps. Most of these applications are running externally facing sites and services. So we can use something like Pingdom or UptimeBot or an external Sensu service or something to just hit the public address to see if the system is up and healthy. And most of the applications have a status endpoint where we can see if it is actually working. Those are usually just a little JSON response that gives you a status okay, status up, worker is okay, that kind of thing. So let me walk through a scripted walkthrough of our procedure. I said walkthrough twice because I like to say walkthrough. So this is the workflow that we're using. Unfortunately, I don't have a live demo, because we don't have anything to deploy right now. We did all that before ChefConf. Like we updated OmniTruck and the download site, and Learn Chef backend got some updates, but we don't have anything to update right now. And so, like, why would I make a change in production when I don't need one, right? These are legacy applications. If we change something, it might break. They also don't change a whole lot. That's why they're actually heritage applications, right? I mean, OmniTruck and downloads aren't, but our little other things are. Anyway, so the procedure looks like this. First, we make changes to the application source repository and open a pull request. So we're using GitHub, right? And this is the workflow that a lot of people who use GitHub get familiar with. And then once we open the pull request, the Buildkite verification pipeline will automatically get run. Then we wait for the Buildkite verification to say that the test passed, and if it didn't, then we can go look in Buildkite and see why. And then we can have one of our ops friends on the team go look at our change and say, yep, it looks good, give it a thumbs up, and then merge. And then you wait. You wait for Expeditor to complete the merge actions, which are the go and build a Habitat package, go and build a Docker container, push those to the appropriate repository, builder, and the Docker Hub repo, and then it will then automatically deploy to acceptance. And then you can go over to your stakeholders in acceptance and verify acceptance with them, and then you can do a promotion to production, and then it will run the deployment pipeline for production. Our previous procedure was more than 5 steps, and many of them were manual. And each of these applications was deployed at a different point in time in Chef's history, and so those procedures were slightly different. This doesn't sound anything like heritage and legacy infrastructure, right? Vintage, handcrafted, artisanal, all organic. So to illustrate, we were literally doing a git checkout. We're going to make some changes with whatever our favorite text editor is. I don't care what your favorite text editor is as long as it's Emacs. I mean Visual Studio Code. I mean Vim. I mean whatever you want to use, it's cool. Then you git add, you do your commit, and you push your branch up, and then you see all your checks have passed. There's no conflicts with the base branch, and we can just pull, or we can just merge. Then Expeditor will do its stuff, and it reports all of the actions into Slack. It also has a dashboard that we can look at and watch if we want to do that, but often we'll just see the things pop up in Slack right away. Depending on the package, some of the packages have to compile no Kogiri, so it downloads the world for that. And then it triggers the build in the acceptance pipeline. That's the thing that actually deploys into Kubernetes. So that line there, once this build is done, we now have an application running in our acceptance environment in Kubernetes, which is available over our VPN, and then we can say, hey, product person, we just pushed this new update to the product, go have a look. And then they'll go over and they'll say, yep, looks good, or no, we need to change the wording on this, and then you go back to step 1 where you do the GitHub pull request, and then it will, when it redoes this deployment on the acceptance pipeline, it will have generated a new version of the application that goes to Docker Hub and the Habitat Depot, and then it will deploy that new thing into acceptance, and then they can go look at it again. And then, once we've determined that, yep, everything's cool, stakeholders think it's awesome, we're ready to go to production, then we do Expediter promote, and you tell it the application you want, the branch you want, and where the environment that it's coming from to go to promotion. Then it gives you a little prompt, and then it performs those actions where it runs the promote.sh script. In this case, that is running a command to set a stable tag on, or stable channel on Habitat Builder, and then it kicks off the build to the deploy production pipeline, which is the exact same pipeline as acceptance. It just says production instead of acceptance. So that's a lot of explanation to have a coworker, after I demonstrated this in a team meeting, he said, wait, that's it? I did my normal thing, right? I committed to GitHub and I pushed the thing up and then we merged it and then we just waited. and then it was available, like, took 5 or 10 minutes, right? That was it. I mean, that's not all, right? I said these are for stateless services only. The stateful ones are run elsewhere, and there's additional things you have to do to configure them. You have to inject configuration into the Habitat package with those scaffolding env things. And one of those things might be the database URL, the database username and password, or the location in Vault where to get those values, and then that can be configured that way. But yeah, so in conclusion, what we found is that we shifted where we focus our automation. We're not focusing so much around the operating system and running a Linux system as a platform. We're running a cluster of Kubernetes as a platform that enables us to be able to run all these heritage applications that are not really getting a lot of changes, but they're still important to the business. And we prioritize the workflow automation. A lot of the automation involved in this is actually in the CI pipeline, where we've done a lot of work aligning YAML so that we can run the right scripts, so that we can kick off the right builds in order to be able to have the right thing deployed to production. And this has a number of benefits to the business. The biggest one is a lower cost by running more workloads using fewer compute resources. Like I said earlier, we reduced the number of instances we're running down to a fraction of what we had before. And operations is a cost center, right? And so we don't want our business costs to be really high in order to run these applications that are important, but not getting updated, right? They need to be there, they need to be stable, and we need to be able to make changes in case we need to deploy a fix to something. And one of the benefits of having moved the legacy applications is that the non-legacy applications like Learn Chef Backend, Downloads, and OmniTruck, we're able to get downloads updated with all the business model change and all the new product information and all that, so that you can find the right versions of Chef Infra and InSpec and all that and be able to get those and download them and provide value for your business. Any questions?
Why did you, I have a question about using EKS or Config as a big
I'm sorry, using what?
EKS or Config in AWS?
So the question is, did you have any thought into using any of the Kubernetes as a service, right? We looked at them. They didn't meet our needs. They were either too expensive for what we could do, or they didn't have a thing that we could validate and verify, and at the end of the day, we need that in order to run some of these applications. Yeah, so, and Amazon EKS had just come out, and when I was right in the middle of this, and I'm like, I'm not gonna halt the world to do this. Yeah.
So you manage your nodes then, right?
Yeah, we manage them. We manage them using Kops, and then they run Chef. Kops takes care of all the, let's get Kubernetes running on them. But Chef takes care of all the users need to be able to log into systems, and we need to make sure that we're not listening to NFS or anything like that. Yeah. Any other questions? Yeah.
Does Buildkite, your process, run within your Kubernetes cluster?
The question is, does Buildkite run within your Kubernetes cluster? And the answer is no. We might set up a Buildkite, or we might set up a Kubernetes cluster to run Buildkite, but generally speaking, no. So Scott and Tom, I think, are going to talk a bit about that in their talk when they talk about the release engineering infrastructure and the things that they learned and did there. But Buildkite runs as an agent, and they have this whole suite of setup scripts and things that is like their best supported way to get your Buildkite agents running. But those agents, I believe, still also run Chef because they need to have their operating systems configured, because they're also going to do Docker in those so that they can build Docker containers and that sort of thing. Any other questions? Yeah.
So is it basically the Habitat packaging that allowed this to be so seamless? Is that to move these applications into containers? Because that seems to, is that where most of the challenge kind of lies?
Yeah. So Yeah. So thank you for coming to my Habitat talk. Yes, so the question is, was Habitat like the reason why this was so much easier? Yes, absolutely. I worked on the Habitat core team for a couple of years, and I got to see the whole thing get built, and worked on some of those early, like the precursors to the scaffoldings. So yeah, having that knowledge really helped be able to port these applications. Yes, it can be a big daunting prospect to repackage your Java applications that you've been running for 17, 20 years, right? But it's not actually that difficult because you've probably migrated it from Hudson to Jenkins or from Jenkins to something else. Like you've repackaged it already. It's just with Habitat, you have to learn like Habitat's places where it puts things, and then you have to write a couple extra like shell scripts to start it up and that sort of thing. But it's not terribly difficult. And so Habitat is not terribly difficult for that. It is effort. But once you have gotten that packaged, then it's actually fairly effortless, as it turns out. Any other questions? I think I can do one more. Yeah.
What else did you assess instead of using Kops for your cluster manager?
So what else did we investigate instead of Kops? We didn't. The other thing we looked at was, okay, so if I want to run all these services on computers, how do I set all that up? And I went through Kelsey Hightower's Kubernetes the Hard Way repository, and that helped me really understand that I don't want to do any of that, and that Kops is going to be pretty dope. So yeah. All right. Thank you so much. I will see you in the exhibit hall or at other things this week.